Hey guys, welcome to another edition of Shelter in Place Festo Ron. Anyways, I'm here to today talk to you guys about HGO and which are our gantries, our handling guide online gantries, Festo built gantries, and how to calculate maintenance interval. A lot of customers have questions about this. How often do I lubricate my axes and such? Very not exactly exact on how to find that information without any type of guidance. So today, that's what I'm going to do is I'm going to show you how to get to this. So basically, I'm going to start with the Festo website, and I am going to type in our HGO for handling guide online. And here, I'm just going to pick one of the gantries here. That doesn't matter. It'll bring me to the configurator. So I'll click on this first option here, and what I'm going to need is the C number. So I'm going to grab a C number here that I already have pre-configured. So I'm going to start the configurator here. Takes a little bit to bring up. So now what I'm going to do is I'm going to go ahead and take that C number and I'm going to paste it into the enter system ID. Assuming this is all pre-configured, either by your Festo sales engineer, application engineer, or maybe you configured it yourself, which hopefully you guys are using this tool to generate systems by yourself without any type of aid, which is kind of the allure of this handling guide online system. But basically here, we have our handling solution. We have a somewhat of a summary. A CAD preview will kind of pop up here shortly. But I'm gonna jump right ahead to the, let's see here, to the technical data, because that's where we're going to want to start. So I'm going to click on technical data here, and what it's going to bring up is this data sheet. Now in this data sheet, what we're going to want to look at, and we're going to scroll down, a couple things. So we're going to want to take a look at the system overview section. Now here is where we're going to find out which series of actuators are for each axis. So, for instance, dimensioning Y reflects the Y-axis, and in here, drive module Y for linear gantry, you see EHMY-LP-EGC-80-TB-KF. That is what's telling us the product family of the actuators. An EGC 80, size 80 with a tooth belt, that's what the TB stands for, and KF, which is our ball bearing guide. And also on the Z-axis, you also have that respectively here. This one's an EGC 70 with a ball screw. So we're going to take note of that, and then going back down to the calculation data here, you guys will see that we have a guide workload, drive workload, and axis workload, all for each axis, one for the Y and one for the Z. Here we've got 27, 21, and 8% respectively. Guide is for the linear guide, linear ball bearing that's built into the axes. The drive workload is respect to the motor that is being used. And the axes is the driving mechanism to create the motion for each axis. So in which case, the tooth belt version, the axes would be the belt itself. And then for the Z-axis, we have a 24% rating here. And that would be for a ball screw, because that is a ball screw Z-axis. So what I want to do is want to take note of each of these values, and then what I'm going to do is I'm going to leave this window open. I'm also going to bring up the Festo website again, and what I'm trying to do here is get into the operating manuals for each of these respective axes. Just so that I don't bore you, I'm going to just do the ball screw version, which is the Z-axis, which I believe is a EGC 70. So here, I'm going to go ahead and click this ball screw linear actuator. We've got different variants here. We've got the EGC ball screw, the tooth belt. We have an HD version of the EGC, and it also comes in ball screw and tooth belt variants. But I'm going to go ahead and click on what our respective configuration is here. The ball screw. So here it's going to bring up the main page for this product, and I'm going to go right over to support downloads. Now we don't have to configure an exact size or stroke here, because all we're really trying to do is get to the documentation, the user manual for this actuator. So I'm gonna go ahead and click support downloads, and then it'll bring up this area here, product information, which is more or less catalogs, brief sales documents and such, some general specifications. What we want to get is the technical documentation here. Now you can either click the text here or expand via this little button. But basically this will bring up all of the technical documentation available that's associated with this axis. We have the axial kits, some displacement encoders that you can get as an accessory for this. But what I'm really looking for here is documentation operating spindle axes. Some actuators may have it listed as this, some might have it as operating user manual, but generally speaking, that's what we're kind of looking at is the operation manual. So I'm going to go ahead and click on that. It gives me a summary of the document, which lists all of the associated products, all the sizes, all the variants, standard variants of strokes. You can ignore this. We don't really need to look at and read all that. But basically what we're looking for here is the revision levels of the documents, which are all listed here. We have one that's from 2008, 2010, all the way to 2018. -04G is the latest revision that we have here. It's usually at the top. So I'm going to expand that, and in that category, I also have subcategories of each of the different languages available for this manual. DE is for German, EN is for English, ES is for Spanish, FR is for French, and etc., etc., etc. So I'm going to click on the English version because I don't know any Russian or French. And that'll bring up this user manual. Now here, what I'm looking for is anything that relates to service or maintenance. In the summary bookmark section here, all of our PDFs are going to be summarized with a table of contents if you're using the PDF Adobe PDF reader. This is native to Internet Explorer here in the version that I'm using. But basically, I'm going to expand service here. I'm going to click on service, and if I zoom in, what you can see here is service. Now here, basically, given any of these parameters, there's going to be a service interval, which is basically the amount of travel that the actuator has to encounter for it to meet its recommended service interval. It could be 10,000 kilometers, it could be 12,000 kilometers, it could be 2,000 kilometers. But basically, in this area, what it's dictating is that if any of these parameters are met, a dusty and dirty environment, the speeds that are extraordinarily fast, etc., etc., the ambient temperatures are higher, you're going to want to lubricate more often. So effectively what they're asking you to do here is to either cut the service interval in half, or even reduce it by a factor of 4. But basically, to get that service interval, what we're going to do here is going to scroll to the next page. There's this graph. Oops, I did not. There we go. This graph. Now this graph, those values that we're looking for, the percentages for the guide workload and the ball screw workload, and for this specific product, I believe, here we go, it says the lubrication interval for the ball screw and the bearing guide use the same graph, which is figure 11. So going back to that, I believe the calculation data for the z-axis was 24% for the ball screw and 19% for the guide. So basically, we'll use the worst case scenario, which is the more heavily loaded item here, which is 24% for the ball screw, and translate that over to this graph. Now, a 100% loaded actuator is going to have a factor of 1.0. And then as you go down, a certain service interval goes up. So at a fully loaded rating of 1.0 or 100% would be a service interval of about 2,000 kilometers. And as you go down, we're at a 25% more or less. Let's put it out around here in the graph. That would probably equate to maybe, so this line is 12,000, maybe 11,000, 11,500 is our service interval. Now you would basically calculate that. Let's say if you're using, if you're stroking 2,000, millimeters a day, you can extrapolate that to the amount of days that you have divided by this this total service interval kilometer, and that'll tell you how much time you have to service, how often you need to service this actuator. But that's basically it. For the most part, the ball screw and the linear guides will follow this graph. If you do have a belt drive, belt drives are somewhat in the Festo world considered maintenance free. We don't have a specification for tensioning or anything like that. Generally, we don't want the user to be tensioning the belts. Now, if you, there are some instances where, you know, for instance, a user may crash the carriage into the end of the actuator, causing, you know, teeth to skip on the belt. That inherently will introduce a level of wear that is unaccounted for in this documentation. That will have to take on a case-by-case scenario. So if for whatever reason that belt is damaged by means of teeth skipping, you should contact your local Festo representative to address that type of situation. But for the most part, if nothing extraordinary has happened to the actuator, you can more than likely expect to have that belt. You wouldn't have to address that belt at all throughout the life of the actuator. But that's pretty much it. You know, it may be a little bit difficult to get to this information without the guidance that I provided here today, which is completely understandable. But you know, feel free to call any of our applications engineers or your sales engineer